Mr. Lucier's chemistry!
Welcome back to Chemistry, guys. We're still talking about acids and bases, and today we're going to conclude our acid-base unit by talking about acid and bases and pH. Well, we started off with the pH scale here. We said anything that has a pH of greater than 7 is basic or alkaline, and anything that has a pH of less than 7 is what we call acidic. And if it has a pH of exactly 7, we call that neutral. Then we talked about concentration. We said concentration is how much stuff we got dissolved in solution, whether it's hydrogen ions or hydroxide ions in the case of bases. Remember, acids, we're looking at how much H plus is in solution. Bases, we're looking at how much hydroxides are in solution. So depending on what we see dissolved, that will be the concentration. Either it's the concentration of the H plus or the concentration of the OH minus. Remember, it can look like this. We have an H plus in brackets, or it can even be the hydronium ion in brackets. It's the same thing. And then for bases, we're looking at hydroxides in brackets. Those represent concentrations, and just don't forget that. So now, we left off by talking about pH, okay? If you want to calculate pH of an acid, all you got to do is take the negative log of the H plus concentration, and that will give you pH. Easy enough. And if you want to calculate the concentration of an acid, all we got to do is take the 10 to the negative pH, and that'll give me the H plus concentration. That's what we did last time. And then we talked about the base side of this. But here's what we said. We said if we take the negative log of the base, the OH, the hydroxide concentration, that doesn't give me pH. It actually gives me this thing called POH. And at the same time, when we want to calculate the concentration of the base, all we got to do is take 10 to the negative POH, and that will give me the hydroxide concentration. Remember, brackets mean concentration. That's how we went back and forth for each one. But you're probably thinking to yourself, well, yeah, we talked about POH, but how do we compare that to the pH scale? Because I said last time, POH, you can't read the pH scale by looking at POH. Well, if I want to figure out if a base is acidic or basic, what you got to do is you got to turn POH into pH. Well, how do you turn POH into pH? It's easy, guys. One simple calculation. The pH scale runs from 0 to 14, 14 being the max, right? So, since we know that, I know that if I take 14 and subtract out the POH, that's going to give me pH. See what I did there? I taught you how to calculate POH, and then all you got to do now is subtract it from 14, and that'll give you pH. Real simple calculation. And flip side, what if for some reason you have pH and they want you to calculate POH? Well, that's easy. We know that 14 minus the pH is equal to POH. So again, real simple calculation. So to flip between pH and POH, all you got to do is subtract it from 14. Now, this kind of looks straightforward, but it's kind of not. So let me give you a quick example here. Last time we talked about a concentration. Let's do this example again. If I have 2.3 times 10 to the negative 7 molar NaOH, what is the pH? So what I would do is, okay, I got to find pH. Well, to find pH, what do I have to have first? Well, you need POH. So I got to find the POH first. So how do I find the POH? You're going to take the negative log of the hydroxide concentration. So let's do that now. I'm going to go the negative log of 2.3 times 10 to the negative 7 and that's going to give me my POH. Okay, so let's do that in our calculator now. Turn this on. Clear it out. So I'm going to go negative log, and I'm going to type in 2.3 second E. So all I got to do is put in the exponent -7, close parentheses, equal. So that's going to give me a POH of 6.6. 6.6. Remember last time you were like, wait, 6.6, that's below here, right? That's acidic. We know this is a base, but it's coming out acidic. Well, no. This is giving me POH. Remember, we cannot use POH to use the pH scale. So what do I got to do to be able to use the pH scale? He has to be in pH. And that's what they want too, is the pH. So how do I go from POH to pH? Right here. Okay. So let's do that real quick. If I have a POH of 6.6, all I got to do is subtract it from 14. So 14 minus 6.6, let's do that real quick. 14 minus 6.6, that's equal to 7.4. Boom. Is 7.4 greater than 7? Yes, it is, right? It's 0.4 greater. So that means since it's greater than 7, what category does it put it in? Yay, it puts it in my base category. So we know that this guy is a base because it's greater than 7. Okay? So it all works out at the end. Remember, if you want to compare it on the pH scale, you have to be in pH. So you got to take your stuff and put it in pH. Now, acids, guys, acids are straightforward. You don't have to worry about nothing. Take the negative log of the concentration, you get pH. 10 to the negative pH, you get the hydroxide concentration. Everything is dandy and good. But if you have a base, you actually have to go through the steps and processes to convert it to pH or away from pH. Okay? So let me give you another example. Here's another example. We're going to reverse everything. This one, we started with the concentration and ended up in pH. Okay? We started and ended up in pH. Now this time, they're going to give me the pH. Let's do this question. If you have a pH of 11.5 NaOH, what is the concentration? So now they gave me the pH and they want to know the concentration of the base. If this was an acid, guys, all I would have to do is 10 to the negative pH, boom, I got the concentration. One calculation, I'm done. With bases, it's not so easy. I got multiple steps here. So let's do our first step. Remember, the only way to get the concentration of the base, what do I need? You need a POH. Well, I have pH here. I need a POH. So how do I get POH? Look at this. All I got to do is take 14 minus the pH, and that gives me POH. So that's my first step, is to go with POH. So let's do that. 14 minus 11.5, let's do it. 14 minus 11.5, and that gives me 2.5. So that gives me a POH of 2.5. So now I have my POH, okay? I have my POH. So step 2, now I can convert it to concentration. So step 1, get POH. Step 2, calculate concentration. Okay? So how do we calculate the concentration? We're going to go 10 to the negative POH, and that gave me the concentration. So let's do that. We're going to go 10 to the negative 2.5, and that should give me my concentration. So let's do that real quick. Let's clear this out. We're going to go 10 up caret, open parentheses, negative 2.5, close parentheses. Don't forget that negative, guys, or you're going to get some big number that doesn't match up. You have to have that negative. Equals 0.003, we'll say 0.003. equals 0.003 molar NaOH. Right there's your answer. That's your concentration of your base. So guys, when you're dealing with bases, how do you know it's a base? Because it has the hydroxide in it. Anything with the hydroxide, that tells you it's a base. Or if they give you a pH, look at this. If they give you a pH that's greater than 7, you know you're dealing with a base. So either case, when dealing with bases, know you got an extra step to convert, okay? To where acids, one step, you're done, right? One step and you're done. Bases takes 2 steps to get what you need to get. Don't forget, bases are giving you POH back and forth. So if you want to convert it, you got to subtract it from 14 and then do it. Guys, if you need to, stop, rewind this video, take notes, but make sure that you understand when dealing with bases, you have an extra step. This is acid and base and pH, guys. I hope this helps, and have a great day.
Stop.